Okay, multiplying and dividing rational expressions. The first two are pretty simple. A rational expression can be as simple as like a basic fraction. So if we look at the first one, simplify each of the following basic rational expressions. When you are simplifying, there's two directions you can simplify on a multiplication problem. You can simplify within the fraction itself, like you can look and say, like, does this fraction itself reduce at all? No. Does the second fraction itself reduce at all? No. Anyone know the other way we can simplify? Diagonally. You can also simplify diagonally, yes. I don't know why that you don't, a lot of kids are not taught this in like elementary and middle school when you're doing fractions, but yes, you can simplify diagonally on a multiplication problem. You can't simplify diagonally on division, but you can on multiplication. So when I look diagonally on these, okay, starting with the 25 over 50, those can simplify. Each of those you can divide by 25. So what will they become? A 1 and a 2. Very good. Okay, simplifying the other direction. Okay, so looking at, I got a 2x and I got an x squared. Will anything simplify there? X, yeah. You can divide this by x and it'll cancel. You can divide this by x and it'll turn to x. So thinking about what we got left on this first fraction, what do we have left? 2 over 1. Good. On the second fraction, we have 2 over x. How do we multiply fractions again? Top times top and bottom times bottom. There was even a little cheer we did in the 7th grade. Multiply fractions. I think I got them. Top times top and bottom times bottom. No? Okay, well. 2 times 2 becomes 4. 1 times x becomes x, right? Every now and then you might be asked to like stipulate what values of x can it not equal. What's the only number could x not equal? 0. So if you want to write that, you can. It's also just kind of mental math. Like, as long as x is not 0. So whatever x stands for, it just can't be 0. Okay, number dos. We cannot simplify on a division problem as is. So what I want to do first on my division problem is I want to turn it into a multiplication problem. How do we do that? Yes, good old keep, change, flip. You're going to keep the first fraction the same, 90 over 7y. You're going to change that division to a multiplication sign, and you're going to flip the second one over. You're basically multiplying by the reciprocal is the technical name, multiplying by the reciprocal. Now that it's a multiplication problem, now we can start checking to see maybe within the fraction itself, does anything simplify? Diagonally, does anything simplify? So looking within each fraction, are we going to cancel anything? No. Okay, next up, I'm going to look diagonally. I can see diagonally, definitely with the 7y and the 4y to the third power, what's going to cancel? One of those y's. So this y and one of these, so I'll have y squared left. 90 and 21. What are those divisible by? Yes, divide by 3. Very good. So when I divide 21 by 3, I'm going to get a 7. When I divide 90 by 3, I'm going to get a 30. All right, so looking at what we actually have left within those fractions. For the first fraction, we got a 30 over 7, right? 30 over 7. For the second fraction, we have what? 4y squared over 7. Do those 7's cancel? No, you can't cancel across like that. You can cancel diagonally, you can cancel with the fraction itself, but not across. Now that I have it simplified, I'm going to do top times top, bottom times bottom. What's my top times top going to turn into? 120y squared over 49. And this one doesn't have a variable on the bottom, so we don't have to make any kind of stipulations like, oh, as long as the variable is not equal to this. Variable can be whatever it wants to be on this one. Okay, on the bottom we have some more complicated ones. They have kind of like a little polynomial expression in the numerator or denominator. Please make sure you rewrite any division as multiplying by the reciprocal first. I even literally do this before I start factoring on these, Because sometimes if you factor first, you're going to be tempted to cancel things that maybe don't cancel. So you're going to rewrite any division as multiplying by the reciprocal first. That's your keep, change, flip. We will need to factor the numerator and denominator then. Then we'll cancel any common factors, aka simplifying it. Remember, you can simplify diagonally across two fractions being multiplied. Or vertically within the same fraction itself. And if you want to, you can actually leave your answer in factored form on these. You don't have to like FOIL it back out unless you just really enjoy foiling. Okay, so the hard part on these again is just going to be the factoring. I'm getting my factoring post-it ready for factoring. All right, the first one, do we need to keep, change, flip on this one? Why not? It's already multiplication, right? So when I look at that first fraction, not a whole lot factors on that first numerator. What's going to factor on the numerator? GCF. What is it, Mason? 2x. Good. So if I take that out, that's going to leave me with x plus 5. On the bottom, though, that looks like, bless you, that looks like a little split the middle factoring. So I'm going to start with two numbers that multiply to a times c, which is 15, but they need to add to 16. What are they? 15 and 1. I'm going to split my middle term with that. 3x squared plus 15x plus 1x plus 5. Group. GCF of the first group would be 3x, which would leave you with x plus 5. GCF of the back group? Just 1. And if you divide by 1, you'll still have x plus 5. So on the bottom, I have 3x plus 1 times x plus 5. Hey, Charles. The second fraction, I usually do the part that looks easier first. So the denominator definitely looks easier. What can we do to the denominator? Yeah, factor out just a little GCF of 2, which will leave me with x minus 7. Okay, and then the numerator does look like one where, again, I'm going to have to split the middle. Two numbers that multiply to negative 12, but add to negative 11. Negative 12 and 1 looks right. Good. Okay, so splitting my middle term into negative 12x plus 1x. Okay. GCF for my first group is going to be a 3x, leaving me with x minus 4. GCF of the back group is going to be a 1, leaving me with x minus 4. So my two factors, one of them is going to be 3x plus 1. One of them is going to be x minus 4. Okay. We got it factored now. I'm going to look within each fraction to see if anything's going to cancel within the fraction. So looking at the first fraction, does anything cancel within there? The x plus 5, definitely. Would this x cancel with this x? No, this one's trapped in the whole parenthesis. On the right-hand fraction, will anything cancel within that fraction? No. Okay. And then remember, you can also look diagonally. So looking diagonally this way, will anything cancel? The 3x plus 1s. Yep. Looking diagonally the other way, will anything cancel? Yes. The 2. Yes. You can cancel just the 2 because that 2 is not trapped with like a 2 plus anything. All right. The first one would be x over 1. The second one would be x minus 4 over x minus 7. And remember, when you multiply these, you can FOIL them if you want to, but you don't have to. You can leave them in their factored form. So in my factored form, if I do top times top, it would just be x times x minus 4. On the bottom, I would have 1 times x minus 7, which is just x minus 7. And what would be the stipulation as long as x is not what? 7, right? Because if x was 7, then the whole thing wouldn't exist because your denominator would cancel. Would any of these x's cancel with each other now? No, because this one's trapped in the parenthesis, this one's trapped in the parenthesis, and the front x doesn't have anything. All right, second one. Doodlers. Okay, second one. All right. First fraction. Let's see. GCF looks like on the top. What would be its GCF? 5x. Good. And if I take out a 5x, I'm going to be left with 1 minus 5x. Good job. Okay. Bottom looks like easy factoring, where we're just going to need two numbers that multiply to -3, but they need to add to 2. What are those numbers? 3, -1, 3, -1. Yep, okay. So I can put those directly in my parentheses. X plus 3, x minus 1. Second fraction. The numerator looks like easy factoring. We're going to need two numbers that multiply to -6, but they need to add to a +1. 3, -2, 3, -2, 2. Yep, those look good. So my two parentheses, one will be x plus 3, one is x minus 2. Okay, and then the denominator just looks like it has a GCF. What is that GCF? 5x. Good. And if I divide by 5x, I'm going to get x minus 10x divided by 5x is 2. Okay, so remember, when we're canceling, we can look within a fraction itself. We can also look diagonally. I'm going to start within each fraction. So within that first fraction, can I cancel anything? Nope. Within the second fraction, can I cancel anything? The x minus 2's. Dink, dink. Okay. And then looking diagonally, okay, what do we see diagonally? The 5x's, good. The x plus 3 on the other diagonal. Okay. So my first fraction, now I have 1 minus 5x over x minus 1. What is my second fraction? It's not 0. It's 1. It's technically 1 over 1, which is just 1. If it was 0, then everything would cancel. We don't want that to happen. So anything times 1 is just going to stay the same. On the numerator, we'll have 1 minus 5x. On the denominator, we'll have x minus 1. As long as x is not what number? 1, because then the whole thing will blow up. Can I cancel those 1s? No, can't cancel the 1s. Can I cancel the x's? No, they're both trapped like in a parenthesis. What's different about the next one? It's division. Do not factor it as division. If you factor it as division, you're going to be tempted to cancel things that don't cancel. So we want to first change it to multiplication. So I'm going to keep the first fraction the same. 4x squared minus 8x over 5x minus 20. I'm going to change my division to multiplication, and I'm going to flip the second fraction over so I have its reciprocal. All right. And now that it's multiplication, now we can start factoring and see if anything will simplify. So on my first fraction, on the numerator, what do I got there? GCF. GCF of 4x. Good. And then if I divide out of 4x, I'm going to have x minus 2. Okay, on the bottom, yep, divide out the 5. Not a whole lot. X minus 4 is what I have left. Good. 2x GCF, x plus 1. And on the bottom, looks like we have a little easy factoring. Two numbers that multiply to 8, but they need to add to -6. -4, -2. Double check. Multiplies right, adds right. Very good. X minus 4, X minus 2. Okay, so again, we're looking within a fraction itself. So we're looking within the first fraction. Do I see anything that's going to cancel out? What about these x's? They're in parentheses. Good. On the second one, do I see anything within the fraction itself? Oh, thanks. Nothing within the fraction itself. Okay, now we get to look diagonally. What do we see diagonally? The x minus 2's. You can probably see why I don't factor it first. If I factored it as division, I would be tempted, this x minus 4 would have been on the top, and I would have been tempted to cancel them when they don't cancel, because now they're across from each other, and those don't cancel. Yes, so that's why I don't factor it whenever it's division, because then I'm like, ooh, should I? No, you shouldn't. Anything else? No. Okay, so if I look at my first fraction, I have 4x over 5 times x minus 4. My second fraction, I got 2x times x plus 1 over x minus 4. Okay, so if I do top times top, I'm going to multiply these. I can multiply these two together pretty easily. 4x times 2x becomes 8x squared. And then what do I do with my x plus 1? Just bring it down onto your answer. Okay, and then on the bottom, I have a 5, and I have 2 of those x minus 4s. How can I write that? You don't have to do that. No, you don't have to do that. Don't have to FOIL it out. Yeah, 5 times that quantity of x minus 4 squared. You don't have to FOIL it out, Danny. Just say there's 2 of them. What's the only number x would not be allowed to be? 4, because then the denominator would turn into a 0 and not exist, and then it would blow up. Okay, a complex fraction. It's like a hole in my paper. Complex fraction is a fraction within a fraction. And we don't want to leave a fraction within a fraction. No, they're not hard. Okay. So the key on these is to kind of try and figure out, like, what is it asking? Oh, sorry, I didn't realize it was so diagonal. What is it asking us to do? So you can see on this first fraction, my numerator is the fraction 5 over x plus 4. My denominator is just an x minus 8. So I kind of have like this bigger fraction bar right here, where I have like this numerator, this denominator. And then my second fraction, again, I have that big division bar where this is my numerator, this is my denominator. Okay, so on the top, if we focus in on multiplying the top together, actually, let me get a Post-it note. I'm just going to literally cover up the denominator so I don't even see it. So I'm going to simplify the numerator first. I'm going to do 5 over x plus 4 times 2x squared. I have a fraction times a whole number, which to multiply those two, you're just going to put this over 1. You'll do top times top, bottom times bottom. What's our top times top? 10x squared. Bottom times bottom, x plus 4. Okay, and then I'm going to look at what my denominator was. Okay, so basically all of these are like, I'm going to put my big giant fraction bar here. Big giant fraction bar here. Okay, so looking at that denominator, I have a 2x minus 8 times a 10x over x minus 4. 2x minus 8 actually does factor. What can I take out of it? A 2 to make it 2 times x minus 4. We sure can. So right here where it says 2x minus 8, remember I really can just make that a 2 times an x minus 4. I'm going to swap that out. 2 times x minus 4. Danny said we could cancel a little diagonally. Basically I can cancel the whole x minus 4 diagonally. Will anything else cancel? No. Okay, so now when I do it's top times top, bottom times bottom, what am I going to get on the top? 20x, good. divided by 1. So looking at this fraction now, this fraction is not fully simplified yet. What does a fraction bar actually mean? Divide. And how do we divide fractions? How do I divide fractions? Keep, change, flip. Which one are we going to keep? The top. So the top's going to stay the same. 10x squared over x plus 4. We're going to change the division to a multiplication, and we're going to flip this bottom one over. So the bottom one's going to flip to what? 1 over 20x. Okay. Doesn't look so scary now. What all could simplify? The 10 and the 20 could be divided by 10. So this would become a 2. And then I could also cancel an x from each one. So this x would cancel. One of these would cancel. So left over we have x over x plus 4 times, what's left over on the second fraction? 1/2. So now when I do top times top, bottom times bottom, the top's going to be an x. The bottom's going to be 2 times x plus 4. If you want to distribute, you can, but you don't have to. And that's as long as x is not equal to -4, because then it would not exist. The second one's actually easier than this one, because this one actually had 2 separate fractions. We had one fraction here and one fraction here. And you can actually see on the second one, we don't have that. We don't have 2 separate fractions. We just have, yeah, just the old one kind of written differently. We have this big division bar, and we know division means what? Yeah, we're going to keep the top the same. We're going to change the division to a multiplication, and we're going to flip the bottom one over. So I'm going to keep this top one, 3 over x minus 5. Change the multiplication, and then we're going to flip over the bottom one. 3x squared plus 30x plus 75 over x squared minus 25. Yes, the bottom is a difference of squares. Does anything factor on this first fraction? No. Let's see. So we'll have difference of squares is going to turn into x minus 5, x plus 5. All right, for the numerator, though, I'm going to come over to my little Post-it. What do you notice about it first? You can take out a 3. All of these are divisible by 3. So if I pull a 3 out front, that's 3 times x squared plus 10x plus 25. Right? Now it's just easy factoring. Yeah. 2 numbers that multiply to 25 but add to 10 are 5 and 5. Anyone remember what that's called when you have 2 identical factors? Perfect square. Yes, good job. Perfect square trinomial. All right. Yes. Good job, Danny. So within each fraction, looking for anything that will cancel, nothing on the first but on the second. Danny saw that one of those x plus 5s can cancel. Okay, what about anything diagonally? No. What a bummer. Okay, so now my first fraction is still 3 over x minus 5. My second fraction is 3 times x plus 5 over x minus 5. So when I go to do top times top, bottom times bottom, we'll have a 9 times x plus 5. And on the bottom, we just have 2 of those x minus 5. So x minus 5 squared, as long as x is not equal to 5. All right, multiple operations, simplifying. I honestly don't think that's any harder than any of the ones we just did. But where I see division, what do I need to do first? Yep, reciprocal. We're going to keep everything on the first 2 the same. 2x squared plus 5x over 3x plus 6 times x squared plus x minus 2 over 2x squared. So this is all the keep. Keep all of this. We're going to take our division sign, change it to multiplication. And what do I get when I flip this last one over? 1 over 2x squared plus 3x minus 5. Alright, now that it's got perfectly set up with all multiplication, we can start looking for factoring. My first fraction, what could I do to factor that? Just take out an x. Yep. Very good. On the bottom, take out a 3. Okay, for the second one, the bottom does not factor, but the top is easy factoring. We'll need two numbers that multiply to -2, but they need to add to 1. 2 and -1? Yes. So x plus 2, x minus 1. Okay, and then for the last one, split the middle. Let's see. Two numbers that multiply to -10, but they need to add to 3. 5, -2. Okay, so I'm going to split my middle term with that 5 and -2. It doesn't matter. It doesn't matter. It doesn't matter. No, it doesn't matter. You get the same final answer. GCF of the first group. X, which leaves me with 2x plus 5. GCF of the back group. -1, which leaves me with 2x plus 5. See, it didn't matter. So one factor is an x minus 1. One's a 2x plus 5. Okay, starting within each fraction. Within each fraction, do we see anything that will cancel within the fractions itself? No. Now we get to look diagonally, the fun part. Diagonally with all of them, yes. Any of the diagonals. So you could do this and this diagonal, this and this diagonal, this and this and this. Lots of choices. You can even do the first and the third diagonal. What can cancel? The 2x plus 5s, that's on the first and the third. The x plus 2, that's on the first and the second. The x minus 1, that's on the second and the third. Yep, you can get rid of an x from the 2x squared, so like this x and one of these. Oh my goodness. What's our first fraction left with? 1 over 3 times 1 over 2x times 1 over 1. So if I did top times top times top, I'm going to get 1 over 6x, as long as x is not 0. Good job.